My name is Fujii from Fujii Consulting and Associates. I'll present on an easy way to learning rainfall-induced landslides and its prevention using analog modeling. Analog modeling is a unique item I produced that helps us to understand landslide mechanism more easily. This is the outline of my presentation. These are 3 examples of activities to teach children about landslides. First is the reason for landslide occurrence using analog modeling. Second is a landslide prevention method using analog modeling. And third is about outreach activities. First, I'd like to explain the trigger for landslides using analog modeling. Let's watch next video.
In this model, brown bottom part is a stable ground or a stable mountain and upper white slice is a sliding mass of a landslide area. In the case of landslide, there is a slippery surface on the boundary between the brown and the white part, like the skin of a banana. Upper white slice is not sliding now. Let's have an experiment. Let's think where rains are falling on this model. It is like rain falling on the mountain, water flooded on the earth's surface and penetrates into the ground or in the mountain in this model. Water infiltrated into the ground from this pipe, and let's see the experiment. In order to penetrate water into the ground, we are pouring water into this funnel through the pipe and water will enter the ground. We are pouring colored water in the experiment so that we can see the water and recognize the water level inside the mountain. Water gradually increases under the slice of the mountain and the water level progressively rises. Because of water, the slice is moving and the house under the slope is breaking down, and the upper houses are tilting. Let's explain the reason of landslide by using this sketch. This is a sliding mass of a landslide, and it is the same as white slice in the earlier model experiment. Red line is a sliding surface and it becomes the boundary surface of this experiment. Please think this red line is a sliding surface of a roller coaster in the amusement park. On this slice in a roller coaster, 10 people are sitting as like this sketch. Let's think about each person. Person number 3 sitting on number 3rd position. He is sitting on a steep place or on a slope, making an angle on the front side of him, and it will slip off quickly. However, there are several persons in front of number 3 and they will push back to his original position. Now, person number 8. This person making an angle with the sliding surface in opposite directions, back side of him. Several persons are pushing from the back. Please look at here. What will happen next? Will this person slip? Each person in this sketch has sliding force and resistance power. Add this resistance power to all the person, number 1 to number 10. Now we can calculate the total sliding force and the total resistance power of this experiment. If sum of the sliding force is greater than total resistance power, it will slip. Under ordinary conditions, when the resistance power is greater than the sliding force, then the mountain is not slipping. Please imagine where is the water level, and please think about continuous rain on a rainy day when it fell on the mountain. When it's rain, water will penetrate into the ground, especially heavy rain or rain continue for a long time. A lot of water penetrating and it's retained into the ground. This blue line will make a new groundwater level by the penetrated rainwater during heavy rain. Let's feel like the 8th person. Think about a bathtub in a house. The 8th person is taking a bath and the water level rise to his neck. When the water level until his neck in the bathtub, then he will lose some weight and feels light. Now I will describe 2 options. without and with water in the bathtub using this illustration. When there is no water in the bathtub, what will happen here? Red arrow, as like this illustration, are same as other people are pushes from the behind in the previous illustration. This person will not move because he has a resistance power enough to stay in the same place. The second case, full of water in the bathtub up to his neck. In this case, this person can move forward easily when the red arrow pushes from the behind. Here, red arrow acting the same force as without water condition. When you take a bath, your body gets lighter because of buoyancy or buoyant force from the water. Then the resistance power will be smaller than without water conditions. Therefore, it is impossible to stay in the same position when the red arrow pushes from the behind in the full of water condition. Please look at this illustration again. Before the rain, water is not present inside the ground. In this case, resistance power is greater than the sliding force. That's why the mountain does not slip. But when the heavy rain falls, the water penetrates into the ground. When a lot of water retains bottom of the illustration, the body gets lighter, resistance power becomes smaller, and the person moves.
Next is the explanation of how to prevent landslides using analog modeling. You'll see next video about some landslide constructions. Of course, it's hard to learn about these things, especially for your friends or children. So how about this video? Let's see.
First, how to remove water from the mountain and prevent mountain slip. Now I will use a model experiment as like our earlier video. In this model, the brown bottom part is a stable mountain and upper white slice is a sliding mass of a landslide area. There is a sliding surface between the sliding mass and the stable mountain. Upper white slice is not sliding now. Let's have an experiment. There is a pipe in this blue dash line. To stop draining water from the pipe, we have added a clip at the end of this pipe. Now we remove the clip from the pipe and let it rain. In order to penetrate water into the ground, we are pouring water into this funnel through the pipe and water will enter the ground. We are pouring colored water in this experiment so that we can see the water and recognize the water level inside the mountain. Water tries to accumulate under the slice of the mountain, but there is no clip at the end of the pipe, so that all the water easy to drain through the pipe from the mountain. As water flows out, water does not accumulate inside the ground. In this way, open the hole in the ground and install a drain pipe. In case the drain pipe does not hit where the water passes in the mountain, we can make a lot of holes in the mountain. Water will escape easily. There is another method to stabilizing a slope using anti-slide piles. As like before, the brown bottom part is a stable mountain and the upper white slice is a sliding mass of a landslide area. Let's place a weight on the upper right side of the sliding mass. If there is no anti-slide measures, it will slide like this. Let's put a red pipe in the ground and place the weight at the same place again. The mountain is not sliding now. The anti-slide piles are used to stabilize large landslides. An iron pipe of about 50 centimeters is used for the piling. This is an illustration of where the pile entered the ground. Now let's discuss how to prevent mountain slip with iron wire, which widely called anchor. Here is two pink plate on the sliding mass of a landslide. We fix the pink plate with two iron wire. Another end of the iron wire we fix with the tape to the brown immovable ground. Now let's place a weight on the upper right side of the sliding mass. The sliding mass will try to move the red direction, but the sliding mass and the brown stable ground is already fixed with the iron wire and it cannot move. This is called anchoring. This is an illustration of anchor entered the unstable ground and it fixed with the underneath stable ground.
The last one is the introduction to the outreach activities. We held a class on landslide disaster for 6th graders. In the first period, we explained about landslides and how to prevent them. The content was the same as in the first video, but of course in Japanese. In this way, by directly showing them the model, they became interested in it. The second period was the field and geological observation. That was explanation of the strata at the actual outcrops and the geology around their schools. He showed the different permeability between weathered areas and bedrock ones. Finally, I'll summarize what we need to outreach. The first step is to create the place to outreach. The next step is to be creative in how you explain. The theme of landslides is a good starting point. It's the best way for children to understand, to explain first what they usually see, and to stimulate their interest in learning more. We never talk, they never know. So, it's important to focus on outreach. Thank you.